numbers we were talking about before, we can produce an image of the Jupiter planet in this case, and then make a special drawing that is afterwards printed in a special printer that makes the image in relief so that it can be touched. And of course, nowadays with 3D printers, anyone can produce 3D objects that can also be touched. And this is wonderful because 3D printers allow us to print virtually anything that we would like to touch, be it planets or telescope models, like in this picture where you can see a model of the Subaru telescope there in blue at the right hand side of the picture. And yeah, for example, we have made a 3D tactile model of the moon, so you can reach and touch the moon. It is a special model because it is a tactile representation of the visual image of the moon. We wanted the blind people to be able to feel what other people see. That means that some bright features in the surface, like the crater rays, have a relief in the model. They are completely flat in reality, but rays are an important characteristic of craters, so we gave them relief in our model, so blind people can learn that around some craters we can see these rays. And in the project that Nuno was talking about before, A Touch of the Universe, we have put together many tactile astronomical items, and we are also developing new 3D models of the planets. If you go to the website, you will be able to download the 3D files for the moon and also for Mars, Venus, and Mercury. And then you only need a 3D printer to have your own tactile planet. This is the final model of Venus after printing and painting. And we have also developed a set of activities to do with the model that can be downloaded from the website. And also a large copy of the Mars model is currently on exhibition at the Príncipe Felipe Science Museum of Valencia in Spain. Okay, so far we have considered sight, touch, and hearing, but we also have taste and the sense of smell. So astronomers do not usually use them for conducting research activities like they do with touch and sound, but they are very useful when communicating astronomy to the general public. And well, they are lots of fun too, of course. In this picture, we have a representation of the solar system made with spherifications. Spherification is a culinary process that employs sodium alginate and either calcium chloride or calcium glucate lactate to shape a liquid into squishy spheres. One can also make a representation of how the density of the universe changed from the Big Bang to our days, or what does the galaxy distribution look like in the universe. To represent the density, the project G-Astronomy proposed to fill a glass with liquids of different densities, starting with smoked mango, which is the densest and will sit at the bottom of the glass, then coconut Malibu, and on top coconut water. And for the galaxy distribution, you can make the structure that you see in the picture just by grating some Parmesan cheese on a hot pan with a little oil or butter in it. And when it is cold, you will be able to see and manipulate a cheesy version of the filaments and voids that make up the large-scale structure of the universe. And well, something which is somewhat more traditional are the chocolate planets. And I believe there are companies who sell them on the internet if you are interested. So let's talk about smell now. The universe is a very smelly place, contrary to what you might think. We have found in the center of the Milky Way the very same molecules that are responsible for the smell of rum, and also those responsible for the flavor of raspberries. And the astronauts who traveled to the moon, you may have noticed that these days we are celebrating the 50th anniversary of the first moon landing. These astronauts said that the dust on the moon smells like burnt gunpowder. And the International Space Station, the scientific lab that is in orbit around the Earth, smells like seared steak. Then Jupiter's moon Io is full of active volcanoes, which throw large amounts of sulfur, so it smells like sulfur. And the Churyumov-Gerasimenko comet, which is the only one that we have studied close enough to know what it smells like. Well, it smells like very bitter almonds, rotten eggs, and cat urine, and all of that mixed up. Pretty awful, I guess, I have to say. So to conclude, we are at least partially blind to most of the light of the universe. To see it, we need to use special telescopes, depending on the kind of light that we wish to detect. But then we have to arrange the set of numbers, which are the telescope's data, into something we can understand. This something is usually an image, but we can also use sound or images that can be touched or three-dimensional objects. Multisensory astronomy is also very useful because every sense gives us a different information. As in the previous example of the transit of the two planets, we can see the actual light of the star dimming, or we can see and touch a plot, in a plot, how the light goes down, or we can also hear the same effect. Multisensory astronomy is also for all the people, regardless of their abilities, because even if you lack one of the senses, just because you are blind or deaf, you can still learn and work on astronomy by using the other ones. And moreover, it has been shown that we remember something better when receiving the information through different senses instead of just one. So it is better to see and hear and touch than only seeing something. So I see I've been really quick with my talk, and this is all. Thank you for your attention. And well, I'm ready to take questions. We have plenty of time for questions.
Thank you, Amelia, for this wonderful talk. I'm just mesmerized because astronomy and space sciences, they are very visual areas of knowledge, and it is admirable that you are making them accessible to people who usually can't do it. It's fantastic. And in fact, looking to your slides and your presentation, I was thinking that this is important to all people that are interested in the cosmos, because I was looking to these pictures of the flavors and the smells of the spots, different spots in our solar system. And for everyone who is interested in astronomy, this is also important, because only looking to pictures, we don't get the full idea of what a spot is. So even for us, that I'm an astronomer and I look to data, look to pictures, but I don't know how it smells in Io or other spots that I could be studying. So in order to have the full picture, we need to use our senses, all of our senses. So your work is important not only for people that have physical limitations, let's say, but to everyone who is in love by astronomy, and by extension to everyone, because astronomy, I think, it somehow concerns to everyone. So this is truly amazing and inspiring work. Congratulations, it's fantastic.
Thank you.
Okay. Okay, so we are going now for our Q&A session. So Amelia, I propose to read the questions asked by our participants within our time limit, and you will try to answer them. Is that okay?
Yes, okay, yes.
Okay, so let me check the Q&A app from Zoom. We have a question from Almira Naradia. I'm sorry if I'm not saying the name correctly. And she asks how astronomers can detect the smells of universe like steak and almond.
Okay, it depends on the case. Let's go back in the and go back on the slides. Okay, in the case of the smells from the Milky Way, we are detecting light that comes from the particular molecules that give out this kind of smell in some things on Earth. So if we identify the molecule that gives some particular kind of smell here, and then we find it somewhere in the universe, then we know that that place in the universe must have the same smell that we are detecting here on Earth. In the case of the moon, it was the very astronauts that went there that this lunar soil or regolith, it's really sticky and it stayed in their spacesuits. So when they went into the spaceship and took them off, they felt this gunpowder smell. So that's the way we detected it on the moon. And of course, in the space station, people are breathing there and they feel this steak smell. And on Io, we think that it should smell like sulfur because it's full of sulfur, and we detect that also with our telescopes from the Earth. And in the case of the comets, these smells have been only detected on Churyumov-Gerasimenko thanks to the Rosetta mission. The Rosetta mission is the European Space Agency's mission that went to this comet, Churyumov-Gerasimenko, and stayed in orbit around it for more than a year. So it was able to capture in situ the gas that was emitted by the comet and analyze it with lots of detail. So analyzing this gas and these emissions from the comet nucleus, the scientists were able to identify the particular molecules that give their smell to bitter almonds and to cat urine and to, what else was that? Oh, I have forgotten now. And yeah, rotten eggs, yes.
Rotten eggs, yeah.
Yeah, pretty amazing actually.
Yeah, it's fantastic. Like I was saying, we don't get the full picture without all that information. So even astronomers traditionally didn't have access to the full picture of the places they were studying, and you are opening that world to all of us. Okay, fantastic.
It's not just me. I mean, there is a bunch of people who are working on this kind of projects.
Yeah, of course, definitely. Okay, so we have another question from Carlos Morales Socorro from Gran Canaria. And he asks, which is your preferred activity with visually impaired people?
I think that my preferred activity is the first one that we carried out, and that was a planetarium show for blind people. That it may sound a bit shocking because a planetarium show it's almost completely a visual experience, but yeah, we thought that it would be great to have a planetarium show for the blind during the International Year of Astronomy in 2009. So we went and see that some other people had done this in Argentina before, and we just follow some of their strategies, and then we made our own adaptations. So in the end, we have a show that could be touched and listened to. So the idea was that we had a tactile half sphere that is here. You can see it on the right hand side. Yes. So this sphere has some constellations in relief on it, so that blind people can touch them. And we had this this soundtrack that was explaining different facts about the universe and the constellations in using sounds. So there was also a projection on the dome of the planetarium, and I don't know if you are aware of the hemispheric planetarium in Valencia. It has 5 different speakers distributed on the whole dome. So we could make, we associated specific sounds to each constellation. And then when the script was talking about one particular constellation, the public could hear a particular sound coming from the speaker, which was lying closer to that constellation on the dome. Wow. So they could have this feeling of the different constellations distributed on all over the dome, just by hearing the different sounds which corresponded to the different constellations.
Very ingenious, fantastic idea.
Yeah, thank you.
Is this session still going on? Is it still possible to watch it?
Yeah, it is possible to reproduce it if you want to, and it was at the Espinho Planetarium also for a while. And, yes, and it went to Lisbon too, to the planetarium in Lisbon for a while. And yeah, from time to time there are planetariums that are showing it again. Just this year in Brussels, during the official celebration of the 100th anniversary of the International Astronomical Union, we had a special session of this planetarium show, and they are planning to show it on a regular basis for schools when the school term starts again in autumn. So yes, I mean, all the materials, all the resources that you need to show it, to reproduce it, are freely available on the website, or just write to me, and I can give you everything you need to do it at your own place. And you don't even need a planetarium. You can do it in a regular seminar room, but of course it's better in a planetarium. But we have done it also with inflatable planetarium, and also just in a regular class. Mm-hmm.
No, that's great. So for the people who are joining us today, if you want to have this special session in your area, in your school, let's say, or in your local planetarium, just keep in touch with Amelia, and she will give you all the details in order to do it. Am I saying it right? I think it's you will provide everything, all the resources you have
yes.
in order to do it, right? Okay.
Yes, and we have the soundtrack now in Spanish, of course, then Portuguese, in English, and French and Italian.
So great, yeah.
Got a few languages by now, yes.
That's great. So for for you guys who are watching us today, feel free to ask questions you might have for Amelia. We are open for a Q&A session. Let me check. I think we haven't received any more questions so far. So we still have some time, so please feel free. Oh, here I have one question now. From Sara Ricciardi. Hopefully I'm saying the name correctly. And she asks, how do you evaluate the impact of those workshops? Because I think those activities are relevant in different areas, so difficult to evaluate.
Yes, we haven't carried out a formal evaluation, but we did have some personal interviews with the participants in 2 occasions. And we usually do, and the other groups that I know in the rest of the world that have also conducted the activities that we propose also have done something like this, just personal interviews after the activities. And it's really very nice. They are really working well. And I have to say that during the activities, people are really very enthusiastic because they are not used to this kind of resources. So it is, for them, it's really very new to be able to touch the moon or the constellations. In one of the workshops that was carried out by Sebastián Musso in Argentina, I can remember there was a lady who was really impressed when holding the model of the moon, and she was saying, but I thought the moon was a disk. Now I realize it's a sphere. Yeah. So far, her own experience of the moon, of course, was in books, and even Braille books or special books for blind people, but they were always 2-dimensional representations. She never had a chance to really to become aware that the moon is a spherical thing. So it's details like this one that make us feel that we are going in the right way. But of course, we would need to, at some point, to establish some formal way of evaluation. And in the case of the planetarium show in Valencia, the first test that we did with blind people, there were some of them who were really very, very moved because they were saying that this experience had made them, had reminded them of when they had vision when they were small kids. They still had some vision, and they were seeing the sky, and this kind of experience with the planetarium had helped them to revive those memories, and they were very grateful for that too. Mm-hmm.
Yeah, I was able to use some of your resources back in 2013 in Porto, and also in 2014 in Brazil. And for people that don't have any limitation in terms of vision, when they look for instance, for the model of the moon, the first reaction sometimes is, oh, the craters or the mountains are too exaggerated. And that is very important for people that are visually impaired in order to perceive the relief. And that was amazing because also either in Porto and also in Brazil, people that were touching the moon for the first time, that was normally the first reaction. Oh, I didn't know there were mountains there, or I didn't know there were these holes, these craters. And for the fact that those elements are a little bit exaggerated for us, we can normally see, that is very important for them to understand the proper relief of the surfaces of those planets. I could realize that.
Yes, it's a little bit like I said before, that when you involve several senses in the learning experience, you really comprehend, you really get the information in a stronger way than when you are just watching. And
Definitely.
So it's important for everybody.
Yeah, for everyone. Okay, so we have one more question here from Aneli Pacheco Blanco. And she asks, what is the most important thing when you design an activity for people with disabilities?
The most important thing is to focus on your public, on the person's strengths. You shouldn't focus on what they are not able to do, but instead you have to focus on the things that they can do. Yeah. And in this way, you will be able to make resources that are accessible to them. So that's the main point. Focus on the abilities they have. Just do not think on the abilities they do not have and try to supply them in some way. No, you have to concentrate on what they can do, which is a lot when you think a little bit about it.
Yeah, definitely.
And it's also a bit of, it's a very creative way, because you have to think in a different ways as you have been thinking just during your whole life. So you have to think how other people think, or try to sense the world in the way that other people sense it. But it's not there is not a right way to sense the world, because everybody has some, in fact, everybody has a learning style, a preferred learning style. Some people remember better what they read, some others what they hear, and some others remember best what they are able to see. So it's important to focus on the particular abilities of your public.
Yeah, definitely. You also have to think a little bit out of the box, right? In order to imagine the proper way to reach people, I suppose. So yes, that's lots of imagination here and creativity, like you said, in order to create these resources.
Yes, it is. I mean, when we first started to produce images from the telescope data, I mean, we could have as well tried to make sounds out of the astronomical data, and there's no reason why they should be images and there should not be translated into sounds. It's just a representation of the reality, and it's the same reality. It's just different representation, and different representations are complementary, and they can give us different informations that will enrich our knowledge altogether. Mm-hmm.
Yeah, of course. Okay, so I'm reminding again the people who are watching us that we are currently under our Q&A session. So if you have questions to ask to Amelia, please write them down on the chat window on your YouTube or in the Q&A app of Zoom. We still have some more minutes left, and Amelia is willing to answer your questions. While we'll wait, maybe I can ask you a question. Do you have any information regarding the big astronomical organizations like ESO or NASA or any other big organizations that are hiring people with some physical limitations in order to become part of their staff? I mean, specifically astronomers. I'm not talking about other areas, because that I know that exists, but specifically astronomers. Do you know if any of these organizations have any astronomer with some physical limitations in their staff currently? Let's say visually impaired people, for instance.
I think NASA has some people who are partially blind working with them, and I do know some astronomers who have become blind after being working for the agency. So it's not that they were hired after they had this blindness, but I think it's the agencies and the large institutions are starting to realize that they cannot just live by ignoring these people, these persons, because they have lots of talent, and they are really giving a lot of benefits to the agency or to institution in terms of knowledge. I mean, just look at Stephen Hawking, for example. If he had been sick before he, like say in primary school or in secondary school, and maybe he wouldn't have been able to make it to the university and then to a research career, and that would have been devastating for us, right?
Exactly.
But instead, we were lucky enough that he had already shown that he was of what he was capable of before becoming seriously ill. And so they were interested in breaking all the barriers that he could have in communication, because they knew they had really important things to give to the science. So it's in this particular case, this is a successful case. But then how many others are out there that we don't know of? And because they don't find a way to overcome these kind of barriers, then these talents are just lost forever for science.
Exactly.
So this is something we have to work on really seriously, that from very young ages, students, children are given tools that allow them to overcome any kind of barriers they may have. And if they show a specific talent for astronomy, for example, to make sure that they can follow that path.
That path, exactly. And it's also, your work is also very inspiring for people that in the beginning might think, because of their limitations, that they do not fit in the world of astronomy, and your work can show them that they can make part of this stuff of young scientists or scientists that love astronomy, and they can embrace that path and become astronomers professionally. So again, this is fantastic. I'm really, I think it's very inspiring what we're doing, and very important for the society in general, not only speaking of astronomy, but for the society in general. Okay, let me check if we have any more questions. Our time is almost up, in fact, but okay, not in the Q&A app, and apparently not in the chat window. So since we don't have more questions and our time is almost up, I think we could call it for the day, for the moment. Yes. And thank you so much again, Amelia, for participating in July's Europlanet webinar. It was a pleasure having you in our session today.
Okay, and I will just leave you with the last slide. So you have my email there, just in case you want to contact me.
Yeah,
so
of course.
Please do it.
Yeah, and if you, again, just to recall what we've said before, if you would like to have, for instance, access to any of the resources, or, for instance, that planetary session that Amelia mentioned, just keep in touch with Amelia, and she will facilitate all the resources she has with you. Thank you so much. So I wish all the best for your work, and I hope you come up with new resources, and in a few years to come, you can talk with people that you have inspired and that then became astronomers or scientists because of your work. That
will be wonderful.
That will be wonderful, and I'm sure it's going to happen. So thank you again, and I wish you all the best, Amelia.
Thanks to you. And thanks to you, and thanks to Nucleo and Europlanet for having me for this webinar. It's been a real pleasure to be with you all. Thank you.
The pleasure is ours. Thanks so much. As for you who have joined us today, thank you so much for attending and participating. Don't forget to follow Europlanet on Facebook and Twitter, and feel free to ask your planetary questions there. You can also watch this video and previous ones on the Europlanet YouTube channel. You can find more information about this webinar in the Europlanet webinars and Galileo teacher training program web pages, whose links will be available in YouTube in the description section of the video. I have an announcement which is not official, but this might be the last webinar of our series. So far, we don't have a date for the next one, but stay tuned because, like I said, this is still not an official announcement, and we might come up with more interviews in the future to come. If you want to be part of the announce list, don't forget that you can find all the information in the Europlanet website. I hope to see you in the next time. For the time being, I'll just say bye-bye, and till next time, Nono out.